Hey there, CJ Math students, and welcome to Math Task number 32, Rational Number Computation Review. We're going to review some of the problems on the Ames webs that have been giving us some tough times. So when we add and subtract fractions with unlike denominators, we have to find common denominators first before we can do anything. So notice you have 26 and 52. Those are unlike. I can't just add up the numerators and keep the denominator, right? First, I have to multiply 26 by 2 to make it become 52. And if I multiply that by 2, I also have to multiply my numerator by 2. So I get 36 over 52 plus 7 over 52. That gives us 43. And then you keep the denominator over 52. Let's do one where we're subtracting. 3 and 4, 6 minus 2 and 1/3. Again, I have unlike denominators with a 6 and a 3, so I'm saying, all right, how do I make this 3 become that 6? Or how do I make that 6 become that 3? Multiply this by 2. Now, you're not always just going to multiply by 2, but in the problems I've given you today, you will. So the first fraction stays exactly the same. The second fraction becomes 1 times 2 is 2, 3 times 2 is 6, and so now you have 3 and 4, 6 minus 2 and 2, 6. Well, you're going to subtract your numerators. 4 minus 2 is 2, and 6 stays the same, and then you subtract your whole numbers. 3 minus 2 is 1. Now we have 1 and 2, 6. You can actually simplify this by dividing both by 2. You get your answer of 1 and 1/3. When we multiply fractions, you're going to remember to multiply straight across on your numerators and your denominators, and you're going to make sure you have no improper fractions. So multiply straight across. 4 times 7 is 28. 5 times 3 is 15. This is improper because your numerator is bigger than your denominator. So I'm going to divide and say how many times does 15 go into 28? One time, that's my whole number, 1. And how much is left over? There's 13 left over. That's my numerator, and I keep my denominator of 15. Let's do one more on that one. So I do 9 times 1, 20 times 20. 9 times 1 is 9. 20 times 20 is 400. It's not 40. You don't just keep the 20. 20 times 20 is 400. And this is totally simplified. You're done, right? There's nothing that you can divide them by. That's a proper fraction. When you're dividing fractions, it's the same as multiplying. It's just you have to remember to flip the second fraction and change it to multiplication. So 8 over 9 stays exactly the same. Division becomes multiplication, and now you have 8 over 7. You're going to multiply straight across. I have 8 times 8 is equal to 64. 9 times 7 is equal to 63. This is improper. How many times does 63 go into 64 without going over? 1 time. That's your whole number. How much is left over? 1. That's your numerator, and you keep your denominator. Let's scoot back to the back side. Again, one more time with fractions. Flip the second fraction, change it to multiplication. So you have 1/5 times 4 over 3. Multiply straight across. 1 times 4 is 4. 5 times 3 is 15. That is totally simplified. It's not improper. There's nothing I can divide them both by. When you're multiplying decimals, remember to multiply normally and count your decimals. So we have 2 numbers behind the decimal here. I have 1 number behind the decimal here. That means my answer will have 3 numbers behind the decimal. 2 times 4 is 8. 2 times 2 is 4. 2 times 1 is 2. So notice I've ignored the decimals until now. I'm done, right? I don't need to do a whole row of zeros. All right? So again, I had 2 in my first, 1 in my second, so I should have 3 in my answer. 1, 2, 3. 0.248. I have 3 numbers behind my decimal. Let's do the one where we have percent of, right? Because this just means multiplication, and you change the percent to a decimal. So we're doing times 0.25. So I have 2 numbers behind my decimal. That means my answer will have 2 numbers behind my decimal. So 5 times 0 is 0. 5 times 8 is 40. Put down both the 0 and the 4. Lay your egg before starting a new row. Now, 2 times 0 is 0. 2 times 8 is 16. Add everything up. We have 0, 0. We have 10. Carry your 1. So that's 2. Your answer is not 2,000. Remember, your answer should have 2 numbers behind the decimal. So start at the end once, twice. Your answer is 20.00. 2 numbers behind the decimal. All right. And lastly, let's do a division problem. Remember to change the divisor to a whole number, then divide. So we're going to swoop once here and swoop once here. We now have 15 into 54. This is our new problem. Put the decimal at the end, put the decimal up top as well. How many times does 15 go into 54? 3 times, because that's 45. You have 9 left over. Your answer is not 3.9. You're going to put a 0. Drop it on down. How many times does 15 go into 90? You already have that decimal there. That was why it's important to put it up top at the beginning. 15 goes into 96 times. You have nothing left over. You're done. 3.6. Last problem. Again, remember, swoop once here, and rewrite it. So 23 into 34.5. As soon as you put the decimal down there, put it up top in your answer as well, right above. 23 goes into 34 one time. There is 11 left over. Drop down to 5. Oh boy. 23 into 115. You should just think to yourself, all right, 3 times what gives you something that ends in 5? Well, that's easy. It's times 5, right? Because that gives you 15. So 5 times 3 is 15. Carry 1. That's exactly 115. You're done. 1.5 is your answer. Let's practice these in groups.